Problem 17 asks us to find the solution to the system of linear equations shown above. Remember, the solution to a system of linear equations is the ordered pair xy that when plugged into both equations creates two true statements. For this problem, I'm going to use the method of linear combination, also known as elimination. The goal is to manipulate or change one or both, if needed, of the equations so that when added together, one of the variables will cancel out. We're going to focus on changing the second equation, multiplying the equation by 3 in order to make the y coefficients match up. We also want the signs to be opposite, and since the y coefficient signs are already opposite in the equation, we won't have to worry about signs. So I'm going to rewrite the equations, showing that I will multiply the entire second equation by a factor of 3. Remember, what's important here is that all terms in the equation must be multiplied by 3. The two new equations I will write here in red. Notice the first one hasn't changed, but the second one, when I multiply and distribute 3 times 2x, I will get 6x. 3 times negative y will give me a negative 3y, and 3 times negative 7 will give me a negative 21. The reason this method is called linear combination is because we're going to do just that. We're going to combine or add together the two equations. When we add a 1x and a 6x, we have a 7x. The positive 3y and the negative 3y cancel out, which is what we wanted to happen. And our new equation is 7x equals negative 21. Now we have one equation and one variable, which allows us to solve for x easily by dividing both sides by 7. We get that x is a value of negative 3. We're not finished, however, because recall, to have a solution we need the ordered pair that makes both equations true. Now that we have solved for x, we can simply take that value and plug it into either one of our original equations to solve for the other variable. I'll choose the first equation. So I'm going to rewrite the equation, but I'm going to plug in a value of negative 3 for x. This allows me, by doing some algebra, to easily solve for y. Therefore, my y value is y equals 1, and I look for the choice that gives me an ordered pair of negative 3, 1, and that is choice B.